Okay, so we've been given this function, and we've been asked to sketch this function. And if we don't remember what the big curly brace on the left means with multiple lines, it means that we have what's called a piecewise defined function. And I like to say that mathematicians and scientists and engineers, we tend to have very little imagination when it comes to naming things. We either name things for the person that discovered it, or we name it for the thing that it does. And this is one of those cases where we name it for the thing that it does. A piecewise defined function is a function that's defined in pieces. And it seems to be something that we're typically not as familiar with as we should be. The big deal here is this comma x less than or equal to 0 and this comma x greater than or equal to 0, because that tells us what portions of the domain that the function is defined to be this value, and what portion of the domain that the function is defined to be this value. And so for x less than or equal to 0, I have outputs defined by this function, by this relationship. And for values where x is greater than or equal to 0, I have, so greater than or equal to 0, they're defined by this relationship. And so I want to graph this thing. Well, I know from the beginning that when I sketch in my coordinate system here, I know from the beginning that this is my y-axis, this is my x-axis, otherwise known as my independent axis, independent, and my dependent axis. And the whole idea is that independent, those are values that I can choose, I can set for x. And my dependent, those are my y values. They depend on what my x value is. When my x value gets fixed, then my y value can be determined. I know because x less than or equal to 0 and x greater than or equal to 0 is the dividing line for this piecewise function, that everything to the right of x equals 0 is going to look like one line, and everything to the left of x equals 0, directly to the left, that looked like it had a down component to it, directly to the left of x equals 0 is going to look like a different line. So how do I actually sketch this thing? Well, let's color code this just for the sake of this demonstration. So let's go with blue for the top row, and let's go with purple for the bottom row, because those are two colors that usually look nice and different from each other. And so the blue line, the top row line, that's for less than or equal to 0. So I could evaluate that at x equals 0 and find out what it is. Well, that's going to be my y-intercept, right? Because if I put in 0 for x, that term gets knocked out, and I'm just left with that for my output. Well, that means that at x equals 0, well, I'm also kind of lining up here my y equals mx plus b, right? So if I do y is my output, y equals, and then mx plus b. My b is going to be a positive 2, and then my m is going to be a negative 1/3 here. If I'm lining these things up, that m is going to line up with a negative 1/3. And so what should I do? I should mark out a grid here. I should put my 2 there, except I should choose the color that I used for that line. I should choose blue. And that's where it's going to touch the axis. And because x is actually allowed to equal 0 here, I'm going to fill that dot in because it actually does get to touch the axis there. Now, what does m equals negative 1/3 tell me? So kind of my for x less than or equal to 0, my b was 2, and my m is negative 1/3. Well, that's my change in y over change in x, right? We probably always heard rise over run, right? Change in vertical change divided by horizontal change. And so that means from left to right, it's going down 1 as it goes over 3. Well, typically, we would do 1, 2, 3, down 1 over 3, and then we'd sketch this in. But we can't do that here. And the reason we can't do that here is because this is not defined, that it doesn't take that shape. for values of x that are larger than 0, and these are x values that are larger than 0, so we can't do that. But what we can do is we can go back 3. Let's do this. 1, 2, 3. And as we go back 3, we would go up 1, because now, let's go with the blue there. Now as we go right 3, we go down 1, and that gives me my slope of negative 1/3. And so I can play connect the dots here, and I have my sketch of that line. Now, that's only the top row, the top piece of this piecewise function. Now we need to sketch the rest of it. Well, that's going to be for x strictly greater than 0. Now, for x strictly greater than 0, we have that our function is x minus 5. Well, if we line up y equals mx plus b, what's that going to be? My m would equal 1, and my b would equal negative 5. And so we could go down here to 1, 2, 3, 4, 5. And we can say that it approaches that value, but it never actually reaches that value of negative 5. So that's why I'm putting the hollowed out circle there. And that's because we're allowed to approach an x equals 0, but we're not actually allowed to reach x equals 0. Why can't I do this? Why can't I have that? Well, because then if I fill this dot in, because that's what putting the equal sign does here. If I fill this dot in, all of a sudden I'm failing the vertical line test, because the y-axis is a vertical line, and that y-axis would then be hitting my quote function, not really anymore, in 2 different places. So I would fail the vertical line test and I wouldn't have a function anymore. And so that's why it's really important that we stay careful about these things, and we use one inequality, one less than or equal to, and then one strict inequality when we're reaching into the same point, unless they meet at the same y value. In this case, they don't meet at the same y value, so we have to use a strict inequality for the second equation. Okay, well, if my slope is 1, that means that my change in y over change in x is a positive 1. That means as I go right 1, I go up 1, right? Or as I go right 5, I go up 5. And so that's probably a more accurate way to sketch this, is if I go 1, 2, 3, 4, 5, and then put in my dot here and say that that's 5 over. And again, kind of connect the dots here and try to make this sketch. And so that is a decent sketch of my function f of x. It's 2 different pieces, right? It's this purple piece for x strictly greater than 0, and that's why the circle there. And then it's the blue line for x less than or equal to 0. And that's why we put the dot on the end of the blue line up high. All right. I hope that helps us remember what a piecewise defined function is, and then how to sketch a piecewise defined linear function in this case, because we'll definitely be sketching linear functions, and as we learn some more about different function types and different transformations, we'll be sketching some more complicated piecewise functions as we go forward. Hope this helps out.